High-powered vacuums can draw a significant amount of current, which could exceed the amperage rating of the arc fault circuit interrupter or AFCI breaker. Wear and tear on the vacuum motor brushes or internal components can cause arcing, which the AFCI breaker is designed to detect and interrupt. It's possible the breaker itself is faulty or has a low trip threshold. To troubleshoot the situation, firstly, use a clamp on ammeter to measure the current drawn by the vacuum. Compare it to the amperage rating of the AFCI breaker. If the current exceeds the breaker rating, consider using a higher capacity breaker or a dedicated circuit for the vacuum. Secondly, disassemble the vacuum and visually inspect the motor brushes, commutator, and any other electrical components for signs of wear, damage, or arcing. If necessary, replace worn or damaged parts. Thirdly, use an AFCI breaker tester to simulate a small amount of arc fault current. If the breaker trips prematurely, it may be overly sensitive and need to be replaced. Fourthly, if the vacuum is not the cause, try resetting the AFCI breaker by turning it off and then back on. This may clear a momentary overload or a minor fault. Fifthly, if the above steps do not resolve the issue, it's recommended to contact a qualified electrician to diagnose the problem further and ensure the safety of the electrical system. Replacing the AFCI breaker without testing or troubleshooting the cause of the trip can lead to repeated interruptions and potential safety hazards. An AFCI breaker is a type of circuit breaker that is designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical conditions that can occur when damaged, worn, or improperly installed electrical wiring creates an unintended electrical discharge, or arc. These arcs generate heat and can ignite nearby flammable materials, leading to a fire. AFCI breakers are more sensitive than standard circuit breakers and can detect these arc faults, quickly shutting off the power to the circuit and preventing a fire. There are two main types of AFCI breakers: branch or feeder AFCI breakers and combination AFCI breakers. Branch or feeder AFCI breakers protect against arc faults in the branch circuit wiring, typically found in older homes. Combination AFCI breakers offer broader protection, detecting both branch or feeder arc faults and series arc faults, which can occur within cords and appliances. AFCI breakers work by continuously monitoring the electrical current flowing through a circuit. They use sophisticated electronic circuitry to analyze the current waveform and identify patterns that are characteristic of arc faults. Normal electrical current flows smoothly and predictably, but arc faults create erratic and unpredictable current fluctuations. When an AFCI breaker detects these fluctuations, it trips the circuit, cutting off the flow of electricity and preventing a potential fire. Several factors can cause an AFCI breaker to trip, including actual arc faults, overloads, short circuits, and nuisance tripping. Actual arc faults are the most dangerous cause of AFCI breaker tripping, as they indicate a real risk of electrical fire. Overloads occur when a circuit is drawing more current than it is designed to handle, which can happen when too many appliances are plugged into the same circuit. Short circuits occur when there is a direct connection between two wires with different voltages, creating a surge of current. Nuisance tripping can occur due to various factors, such as electromagnetic interference, faulty appliances, or overly sensitive breakers. Troubleshooting an AFCI breaker that is tripping frequently involves several steps. Firstly, identify the circuit that the AFCI breaker protects and determine which appliances and devices are connected to that circuit. This will help you narrow down the potential causes of the tripping. Secondly, inspect the wiring and outlets on the circuit for any signs of damage, such as frayed wires, loose connections, or cracked outlets. Repair or replace any damaged components. Thirdly, test each appliance and device connected to the circuit to see if any of them are causing the AFCI breaker to trip. Plug each appliance into a different outlet in the circuit, one at a time, and see if the breaker trips. If the breaker trips when a particular appliance is plugged in, that appliance may be faulty and need to be repaired or replaced. Fourthly, if you suspect nuisance tripping, try replacing the AFCI breaker with a new one. AFCI breakers can sometimes become overly sensitive and trip for no apparent reason. Replacing the breaker may solve the problem. If the AFCI breaker continues to trip after you have tried these troubleshooting steps, it is best to call a qualified electrician to diagnose and repair the problem. An electrician has the tools and expertise to identify and fix complex electrical problems safely. Several common misconceptions exist about AFCI breakers. One misconception is that AFCI breakers are only required in new homes. While AFCI breakers are now required in many new homes, they can also be installed in older homes to provide added protection against electrical fires. Another misconception is that AFCI breakers are a replacement for ground fault circuit interrupter or GFCI outlets. AFCI breakers and GFCI outlets serve different purposes. AFCI breakers protect against arc faults, while GFCI outlets protect against electrical shock. Both types of protection are important for electrical safety. Here are some additional tips for working with AFCI breakers. Always turn off the power to the circuit before working on any electrical wiring or components. Use insulated tools to avoid electrical shock. Follow the manufacturer's instructions when installing or replacing an AFCI breaker. If you are not comfortable working with electricity, call a qualified electrician. Regularly test your AFCI breakers to ensure that they are working properly. To test an AFCI breaker, press the test button on the breaker. The breaker should trip, cutting off the power to the circuit. If the breaker does not trip, it may be faulty and need to be replaced. AFCI breakers are an important safety device that can help prevent electrical fires. By understanding how AFCI breakers work and how to troubleshoot them, you can protect your home and family from the dangers of electrical fires. In the specific case of the AFCI breaker tripping when a vacuum cleaner is used, the most likely cause is either an overcurrent or arcing in the vacuum motor. Vacuum cleaners, especially high-powered models, can draw a significant amount of current, particularly when starting up. This surge of current can exceed the amperage rating of the AFCI breaker, causing it to trip. Additionally, the brushes and commutator in the vacuum motor can wear down over time, leading to arcing. This arcing can also trigger the AFCI breaker. To address this issue, firstly check the amperage rating of the AFCI breaker and compare it to the current draw of the vacuum cleaner. You can find the current draw of the vacuum cleaner on a label on the vacuum cleaner itself. If the vacuum cleaner draws more current than the AFCI breaker is rated for, you may need to use a different vacuum cleaner or have a dedicated circuit installed for the vacuum cleaner. Secondly, inspect the vacuum cleaner motor for signs of wear or damage. If the brushes are worn down or the commutator is dirty, this can cause arcing. Clean or replace the brushes and commutator as needed. Thirdly, test the AFCI breaker to make sure it is working properly. You can do this by pressing the test button on the breaker. If the breaker does not trip, it may be faulty and need to be replaced. If you have tried these steps and the AFCI breaker is still tripping when you use the vacuum cleaner, it is best to call a qualified electrician to diagnose and repair the problem. An electrician can use specialized equipment to identify the source of the problem and ensure that your electrical system is safe. Remember that electrical work can be dangerous, so it is always best to err on the side of caution and call a qualified electrician if you are not comfortable working with electricity.